Good afternoon, everyone. A warm welcome to today's webinar, Simulation Powers Sustainable Innovation. I am Ajay, Senior Marketing Executive at EDS Technologies, will be the host for today's webinar. Before we start our webinar, I would like to give a quick brief about EDS Technologies and Dassault Systems. EDS Technologies is the largest engineering and enterprise and mining solution provider in India with over 2 decades of experience in various industries. We enable companies in aerospace, automotive, industrial machinery, high-tech, electronics, consumer packaged goods, and various verticals to achieve their business goals. EDS Technologies is established in 1995, is headquartered in Bangalore. The company operates with direct presence in India in 13 locations. It has the largest customer base in the Indian market in PLM, ERP, visual simulation, and have successfully partnered with more than 1,500 customers in various business verticals. EDS Technologies have established the privileged position in market and partnered with many global key players like Dassault Systems, SIS, VTMAC, COTS Visual Simulation, PLM training, and trained on-site resources, bringing the most complete solution for any size of company. Today, we are presenting about Telmia, one of the core solutions from Dassault Systems for manufacturing industry. We have our speaker for today, Mr. Nagananda from EDS Technologies. Nagananda has started his career in automotive component design and development and has a decade-long career exposure in new product development and finite element analysis and optimization. In his current capacity in EDS Technologies, he is supporting and training the customers to solve problems in SIMULIA side. Over to you, Nagananda. And if you have any queries, you can please post it in the chat box. We will be resolving the queries at the end of the webinar.
Thank you, Ajay. Thank you all for joining this webinar on Simulation Powers Sustainable Innovation. In today's market, it's always it's a brand and dedicated to the making. So realistic simulation and integral business practice and explore, discover, understand, improve. These are all some of the buzzwords that we hear in order to sustain in the market, competitive market, also to bring our product to next assembly level or to the market. So there we can work out to increase the profit, and thus by reducing the man-hour, machine-hour, method, time, money, etc. So in this session, let us understand the different tools available from Dassault system to help our product design and development at a much faster and effective way. Here we have an example wherein which you can see the simulation happen at the top image, and in the bottom image you can see the realistic experimental result. So it always depends on multiple factors, whether it is evaluating the design alternatives or reducing the prototype, increasing the confidence in product performance, accelerate the design decision, and gain the knowledge of real world behavior. So always you can depend on the particular tool, which in order to avoid the intermediate certifications, directly you can go for a final certification with examples. Here you have a image which says about the physical testing and also onto the real-time experimental image, which says about the simulation which is happening on the right hand side, and also the image that is practical testing on your left hand side will provide you a similar result. So instead of putting your energy, money and information in testing right from first time, you can depend on your realistic simulation to get the result. So when I speak and when we understand about the SIMULIA product, so Dassault Systems has come out with 4 different products that we are going to understand today. So there are 4 different products. One is for Unified FEA, and the second for Topology and other optimization, another for parametric optimization, and fourth for fatigue and durability analysis. Similarly, it helps us in ease and complementary technology access, flexibility, scalability, and openness, and manageability and IT benefits, and collaboration and automation using this tools, and is also called as power of portfolio business values. When we discuss about the Unified FEA, topology optimization, and other tools, there are the tool names which are more prominent and used, tested by the industry leaders, which has their results correlated with the experimental results. So I have today I'm going to explain you on Abaqus Unified FEA, Isight, which is process automation and design optimization, Tosca, which is non-parametric optimization, and FESAFE for fatigue and durability analysis. When I say about these SIMULIA products, which is being used across the verticals, as you can see on the screen, whether it is a consumer packaged goods or life sciences, in the knee, hip replacement, and some surgical equipments, living heart analysis, or whether in the aerospace and defense organizations, where you can look and work on composites and different system level analysis. Again, in aerospace and transportation, you have Abaqus being used, or SIMULIA being used across the verticals, in the, like for example, tire or interior or crashworthiness, brake, power, etc. And then in high tech, you have, like in a drop test, vibration analysis, and semiconductors or handheld devices, etc. In architecture and construction, it's being used in analyzing the seismic analysis and bridges and dams, okay, where we can do the fluid structural interaction type of analysis. Again, it's being used in industrial equipments as well as in thermal and energy nuclear power plants. Let's understand this particular tool, Abaqus Unified FEA. This model is having CAE, which is called as Complete Abaqus Environment, which is being used for pre and post processing, whether it is for modular or well organized structure, or which is very easy to learn, an object action paradigm, okay, a well-built model tree which helps us in modifying, editing the values, whether it is from boundary condition or in loads or in certain models. So these things can be done with pre-processing and being used as Abaqus CAE. And then we have a tool which helps us in importing the CAD model, whether in the neutral formats like STEP IGS or VDA STL, or with add-on associative interface, we can import the model, CAD model, from the respective CAD tool, and in certain case it is bidirectional, and certain CAD associative interface are unidirectional. So apart from that, it has a capacity to import the Nastran and ANSYS input files to further analyze in Abaqus. And coming to the next module, here it is the meshing module which is inbuilt in Abaqus, and one which we can do the fast automatic free meshing or its manual meshing, semi-automatic hex meshing. Okay, in this particular thing, module, when the model is being used for meshing, it provides in three different color conditions, whether it is in orange, yellow, or green. Where which, if it is in orange, we need to partition and use it for further mesh purpose. Again, the same CAE is being used for visualizing the results, whether it is in the form of high performance large models, automatic color codes, transparency, view cuts, animation, probing XY plots, path plots, etc. And also, macros can be written here in Abaqus by using a Python scripting, where in which if you are using the model with for repeated application and only as minor changes need to be done. So in that case, you can definitely write a Python script. But having said to use Abaqus CAE, learning Python script is not mandated. Coming to the solvers, we have two solvers in this. One is Abaqus standard for which is based on implicit solution techniques and for linear and nonlinear behavior. Similarly, which is being used for static stress and displacement, dynamic analysis, mode-based linear dynamics, heat transfer, coupled field analysis, acoustics, and etc. Similarly, the second tool is Abaqus explicit as far as solver is concerned. Here it is being used for explicit time integration, and which is intended for high speed and transient dynamic events. And also here in the range of solution procedures in terms of stress displacement, thermal, acoustic, structural, and coupled Eulerian Lagrangian analysis, apart from a blast analysis or a drop test analysis or deep drawing analysis, etc. Abaqus has a feature which helps us in understanding the extended finite element method to understand the crack initiation and the propagation. So we have cohesive elements technique as well as virtual crack closure technique in this arena. Apart from this, Abaqus even have the inbuilt library of MBD, that is multi-body dynamics or kinematics. We have enough connectors library which we can use for further analysis. So on the left hand side you can see a flap mechanism. On the right hand side it's a hybrid form of analysis mechanism as well as analysis being done on a particular assembly in the landing gear. It's a real engineering problem that can be solved with using this Abaqus Unified FEA, and we can get the different results as we do modifications in terms of mesh, which is called as mesh convergence, and also being used by the industrial leaders, tier 1, tier 2 suppliers to get the results which can be correlated and validated with respect to a hand calculation or an experimental test. A summary which says about Abaqus is a unified FEA. A standard and explicit can be used in this. A co-simulation with standard and explicit can be done. A pre and post processing using an easy tool called CAE. A generalized contact facilities available, and so on. Coming to the next tool, that is fatigue and durability. When we do any manufacture any product or design, and then there will be a phase of design and prototype. But always there will be some lag, that is some 12% of the manufactured goods, either because of delay or some other in-service products, maybe because of the launch delay or warranty claims, the recalls and legal liabilities. There will be a shoot up in that time, that is a delay or the lag in the time, and also there will be shoot up in a cost of failure. So how we can bring out this in our manufacturing sector so that we can reduce the prototypes as well as delay in time, so that in the first go itself it should reach to the customer with a good design as well as should be used in the manufacturing. Here is one example which is on the Land Rover from Jaguar. There was a problem in terms of using this product, and later covering that using the FE-Safe Turbo Life, the lower cost alternative material with improved costability, which has led to a multi-million pound per annum cost benefits, and it also reduced the failure and the number of engine tests from 5 to 1 in the realistic, and it was achievable. So what will make us to use this particular fatigue analysis? Before going to that, let us understand how this works. In any industry, we can find the design, and there will be designers. So this design will be used and by the engineers to do the finite element analysis. Once it is done, then we will be having the ODB results. So once this result can be taken as an input for FE-Safe at fatigue tool, and also we can take the road load data and also the material properties. We can do the analysis to find the failure or the initiation of the crack, and it also explains as where in which location we can find the crack and what cycles, how many cycles are leading to initiate that particular crack, and the durability and the life prediction. So these are all some of the supported inputs and output from these tools, which can be used in Abaqus FE-Safe, and also some of the supported output details as here. So in general, usually organizations will be depending on their traditional method in order to find out where exactly the failures are, and in the spreadsheet there are possibility of missing certain locations or the nodes where the crack might have happened. So it is also very difficult to understand and find out the problem or the initiation of the crack on the spreadsheet in the complex loading conditions and structures. So what we can do in that scenario is, there is always a thinking that whichever the maximum stress region will be the shortest life region, but in actual scenario it is not the same. So maximum stress location may be different, and the shortest life or the initiation of the place may be the different. So if we understand this, you have an example from Hyundai which explains. In the center you can find the picture which says about it's a high cyclical fatigue. So in that case you can see in the lower cycle fatigue, you can see that in the upper image it is experimental result, and the lower image it is the fatigue result from FE-Safe. So here with low cycle fatigue, you can see the crack initiation at a place near to the notch, and it resembles both the results. When we use high cycle fatigue, in that case also it's a uniform high cycle fatigue. You can see the crack initiation at one particular location, which is near to the notch, and it resembles, both the results resembles. And in the third picture, it is a combination of it's a combination of both the cycles, that is high and low cycles. So you can see the crack initiation at one particular location away from the notch in the result, FE-safe result. You can see the same location, and the crack has happened at the same location in the experimental setup also. So it also depends on loading sequences, not only the high stress or the maximum stress location. Apart from that, so manufacturing effects also need to be taken into account. With this use, like with FE-safe, you can see optimize the design for minimum weight or cost, and same time and money with right first time prototype testing. Evaluate the different material options, design and validate fatigue test programs, and reduce product recall and warranty costs. So you can trust FE-safe because of multiple reasons, which includes the pioneers in modern multi-axial strain based methods and technology driven. It's a highly qualified specialist supports and teams from Dassault Systems and also from EBS we can support. And 60% of the PhD holders are available worldwide in FE-safe to support us. So with base FE-safe, we have certain other modules which includes thermo-mechanical fatigue, TMF, creep fatigue for turbo life, and fatigue elastomer using FE-safe rubber, and also fatigue weld joints using the Verity. Some capabilities in understanding the standard version of FE-safe, which includes stress life, strain life, infinite life, and fatigue of cast irons, and so fatigue related weld using the BS 5400 and 7608, etc. It also has a capability to have the more than 350 material which can be included in this one, which are included in this one, so that can be used with material properties, chemical compositions, and fatigue properties, etc. Which can be used along with the FE-safe. There is another tool for parametric optimization, so that life estimation can be done live along with certain other products. It has a capability to interact with ANSYS as well as ANSYS result files, and multiple upstream systems can be linked, in which case FE-safe appends FE solutions. Inaccurate results are always unreliable results. So in order to find accurate results, so you have to find the correct fatigue hotspots, optimize your design for fatigue, and also increase confidence that your component will pass test as right first time. Okay. Here we have certain examples which can be checked. Like here you have a uniaxial analysis being done with the fatigue test, the fatigue testing of the helicopter The final fatigue life of the rotor hub is 985 hours, and the efficient calculated result is 934 hours result. And also this particular product is fast, it's speed, it speeds up the analysis with the said uh, hardware. We can go ahead and get the results with at faster rate. There is no trade-off between the speed and accuracy. The unique nodal elimination method in FESAFE ensures that you get your result quickly and correctly, regardless of the complexity of the analysis. And parallel processing is automatic, and distributed processing is also available. The speed examples shown in the using FESAFE out of the box, no setting required to force the user to choose between the speed of analysis or accuracy of the result. Here we have three examples where which three industry leaders have used this product and with their results displayed on the screen. One is from Ford Motors, another from Schaeffler, and Eaton Automotive. There are some references from the industrial leaders from Caterpillar, Belkin, Dana Automotive, Patton, Miller, and also the association of FESAFE with certain other your existing products, so that the input and output can be taken into FESAFE seamlessly to get the fatigue and durability life of the products. There are certain list of users across the globe. To discuss on the next product, that is Tosca, that is non-parametric optimization product, in order to reduce the weight and increase the stiffness, also to remove the material from the strongest point excuse me, and add material to the weaker point in order to make the model sustainable and to complete its operation under operational loading conditions. Two sets of information are available on the screen. One is non-parametric method, another is parametric method. So in here, currently we will discuss on the non-parametric method, and later we discuss on the parametric methods. There are four important aspects in Tosca structure, that is topology optimization, in order to maximize the stiffness or minimize the weight, and which is used in innovative designs. So there is another product called Tosca structure sizing, which is for reducing the mass through optimized sheet thickness. And third is shape optimization, which reduces local stresses and increase the durability. And fourth one is bead optimization, which is used for increasing the stiffness or eigenfrequency of the sheet metal structure, which can be used to accelerate the product development. A realistic optimization, which results in considering the non-linearities in the picture. Full design freedom for design optimization, seamless integration with leading FEA and CFD solvers. Usually what happens, the industries will be having a FE, a CAD, FE, and the prototype and experimental result. But having said, when the product is being developed and designed and analyzed, and prototype will be made so that it can be tested and which can be sustained in the market based on the operation loads and also cost wise and material. But having said, there is an issue that usually the industrialist will sign an agreement much before the product launch, saying that for a matter of 3 years or 5 years of pre-described time slot, they are not going to change the price of the increase the price of the raw material, even though there is a fluctuation in the raw material market worldwide. But here always there will be difficult, and the industrialist or the manufacturing sectors will be under high pressure in order to cope up to the cost and also to be more sustainable in the market. So always it is better to use a tool like Tosca Structure, which helps us to reduce the material and increase the stiffness so that it can withstand the operational load and can be sustainable for a longer period in the market. So here we have a Tosca Structure product which is a stable and fast optimization algorithm which has an interference to Abaqus, ANSYS and MSc Nastran, which is seamless integration into your CAE environment, which can be used, which can be available with both Linux and Windows capabilities, which supports all the three non-linearities, whether it is in the form of contact or material non-linearity or boundary condition non-linearity. All three non-linearities can be easily handled with this particular tool. Here we have a procedure with an example. We can see the initial design space and the finite element method is being done, and there are two regions where the constraints have been done and the loading conditions will be there, so that these are frozen region which cannot be further used. The rest of the region can be called as, can be used as a design space to further reduce the material wherever it is a stronger point, and wherever it is weak the material can be added. And then the smoothing operation is done, which is taken into validation CAE tool to validate that, and shape optimization can be done, and then later it can be taken back to CAD, and then prototype can be done and testing can be done, and which can be used for in the next manufacturing assembly or in the market. Some of the CAE preprocessor and post-processor tools on the solver tools that, as we can see here, we can see the CAE tools as well as solvers on the screen. Here we have an example from Audi, so which says about the successful reduction in material and parallelly sustainable to the operating loads. So it's a significantly shorter development time, so which helps us in design process and start with a very good design proposal and preconditioning of a final design and a high quality design which saves material, weight and fuel. Also, we can see the multi-objective min-max formulation for several objective functions, and it supports of linear and non-linear material. So, automatic validation and data preparation for CAD transfer, and also 3D animation sequence and result and sensitivity plots can be seen. There is a second set called sizing, which can be used for non-parametric optimizing sizing approach, which can be used for large-scale applications with up to a millions of degrees of freedom, and also the clustering of shell elements thickness to combine design variables. Here is an example where in which some 3 lakhs plus shell elements are there, and initial weight is 329 kgs, where in which a considerable reduction in weight and also 198 shell sections used as cluster design variables, which will be used to minimize the mass and stiffness constraints like bending, torsional and axial stiffness. We have shape optimization result where we have fast improvements of existing FE model, a reduction of stress concentration, increase of durability, and increase of natural frequency, and no need to create a shape basis vectors. So with this, which helps us to volume constraints, unlimited number of load cases, mesh independent manufacturing constraints of casting, forging, stamping, extrusion, drilling, minimum and maximum number of size, penetration checks to neighboring parts, and also in each design cycles to keep the mesh quality during the optimization. We have fourth module called bead optimization, which helps us in determines an optimum location and orientation of beads in sheet metal structures, which also helps us in time saving automatic run bead calculations of only 2 to 3 solver iterations, which helps in clear bead layout for complex models, innovative direct producible beads, which helps in considering the manufacturing restrictions during the optimization, which helps us in compliance and displacement, natural frequencies, system symmetric constraints, a mesh independent approach, and clear results for a precise interpretation. Tosca also has the features to view the results and also to produce the report in the form of VTFX formats, 3D viewers of the models, and as well as 3D animation plots. Here is the procedure of smoothing and generating the validation inputs, and also the STL and IGES CAD compatibility formats available, and also the CATIA Wi-Fi geometry using RSO. You can re-engineer the shape results. The technology, integration and performance related Tosca can be a leadership in technologies for optimization by customers focused development and joint symmetric research projects. And the fourth tool which is incorporated in SIMULIA is Isight, which is a parametric optimization tool which can be used in the analysis, wherein which industry will be using a third-party tool, a CAD tool or a CA tool, as well as inbuilt programs like C, C++, Java code or Python scriptings, as well as their own testing rigs, experimental setups. So in order to take these data from multiple different clusters and to make technology like including the topology techniques like DOI studies or optimization to get the optimized result. And to make this, we have to make the use of all these applications in order to like standardize and reduce the difficulties. So business cannot consider enough design alternatives in the time available for product development. So this can be reduced by using Isight, a parametric optimization in their day-to-day analysis. So this automated process will help us in engineers to define the simulation process and design goals, automated input generations, run and output extraction, systematic search of space, also sustainable, which is suitable for frequently used applications, many constraints, many degrees of freedom, and multi-step conditional simulation flow. Isight is a framework software package that is used with existing simulation codes built and execute simulation workflow. This is the coat hanger like structure in which we are using the multiple techniques, which is in the form of DOE, optimization, Topology, Six Sigma. As well, we can use the core components and the premium components like ANSYS or MATLAB, as well as calculators or Excel sheets or in-house scripts in order to get the results. So benefits of using Isight, which reduces the design time, improve the quality, and understand our designs. So we have the components, whether process components or application components, which includes the approximation, DOE, Monte Carlo, optimization, Six Sigma, etc. In case if you are having Abaqus need to be incorporated in this one, there is a process which can be used, the inputs, outputs, and the batch file of the Abaqus to find the result based on the DOE studies. A simulation process flow automatic data exchange with CAD, automatic data exchange with Abaqus input files, ODB files, and executionable files, so that we get the required results. A SimFlow or Simcode is a tool which is used to find the result of a tool wherein which we have certain inputs and certain outputs. We need to map and get the best result out of that. We have a process flow authoring simulation wherein which the parameters will be mapped using different inputs and outputs to get the required results. So we have optimization and design exploration wherein which DOE, optimization, Monte Carlo, Six Sigma, etc. tools are available. So here is an example wherein which there are set of candidates which can be used to understand the design exploration. So those candidates are taken into a region where we have a feasible and infeasible region and also a constraint. Based on the iterations and the inputs, we can call out the best candidate which can be used for further DOE studies or some other optimization studies. Here we have an optimization DOE study which says about the perform trade-off and understand the design space capabilities to determining which input variable have the most influence on your simulation output, and also parallel execution used to build approximate models and estimate the optimal design. So approximation tool is available, which is a mathematical model that approximate the relationship between the set of inputs and outputs. We have Monte Carlo to find out, modify the inputs about a nominal values by applying variances through a distribution curves. We have design optimization, the DOA study which is done, and for the different iterations we have found the best result that can be taken further to identify the best result out of which the optimized result. And we can also do the Six Sigma results in order to find the reliable and most feasible, robust and reliable design. We can also use this in the probability of failure and mean and reliability check by using this particular tool. Here is an example which says the optimized result, a captured data, wherein which you can find the green color which says about the best result and red are infeasible results. We have the results which can be plotted in 1D, 2D, 3D plots, and also the you can visualize the results in the value like in real-time plots, and data mining is also possible. Some of the worldwide users using a tool, Isight tool across the world. Here I have an example which says about the brake optimization. Here, let us understand the physical behavior of a component which has a structure and thermal analysis being done using Abaqus. And then we have the parametric optimization, exploration of design alternatives in Isight. And then we have used topology optimization, Tosca structure, to conceptual lightweight design, and then the shape optimization using the Tosca structure to improve structural integrity. First, let us understand the analysis being done using the model. Here, the friction-induced heat leads to brake fade. Because of this, a wear and tear happens, a noise will be there, and the vibration issues will be there. Uneven thermal band of disc leads to a variation in thickness and brake torque, as well as fully coupled thermal mechanical analysis is required to analyze this particular analysis. A frictional induced heat which may affect a parameter such as friction, coefficient graph, etc. is being done. The analysis results are plotted. A design of experiment study can be done to minimize the distortion and study the sensitivity of brake performance on different disc and pad. So here we have a Abaqus result which says about the detailed geometric creation meshing scenario defined in the Abaqus standard, and also the analysis of bolt loads, subsequently moving the loads to mimic the loading of the brake discs. So parametric optimization to explore the design alternative, which says about the brake fade is caused by the accumulation of the friction induced heat due to excessive braking. Vents holes are created in order to cooling, but should be designed without affecting the strength and performance of the component. So using Isight, the parametric optimization can be performed to maximize the cooling. The brake area is provided as a constraint with more than or equal to 95% of the disc surface. So once the result is being plotted, we have the optimized result. Vent hole radius of reference were 4.0 mm. Optimum is 2.4 mm. Number of hole segments was 6 earlier, now it is 24. Vent hole angle earlier is 8.0, 7.0 is optimum. And maximum nodal temperature was 286 and it is 256 degrees, that is some 30 degrees reduction. So also the conceptuals using the brake disc should be should be stiff to reduce distortion during the braking, and also reducing the weight of disc can reduce the inertia and ease braking. Constraints imposed on volume was less than 40% of design space, and restrictions include cyclic symmetry, manufacturability through stamping. So we have the result help in the Tosca results, which says about the weight carrying capacity was 292, the optimum can be like 205, and maximum displacement was 1.1, and later it was 0.6 mm. So now this unified power, that is power of portfolio, this extended tokens, the same set of extended tokens can be used to analyze whether it is Abaqus Unified FEA, Isight, FESafe or Tosca on same set of GUI, that is QAX, what we call, can be used to do the pre-processing and post-processing in all the four tools. So using this is more economical, which is more simple, scalable, and which helps us in reducing that time and thus contribute to the development of the industry. Thanks for your time, and if you have any queries, please let us know. And also, for a detailed presentation, please reply to us. We will visit your organization and provide you a detailed domain-based, product-based presentation and demonstration. Thank you.
Thank you, Nagananda. If you have any queries, please post your queries, or else I can unmute you if you just hand raise. So this will be answered by Mr. Nagananda.
Hello.
There is a query from Mr. Dharmendra Kumar. He asks, does Abaqus support GPU acceleration?
Definitely. It has a capability. If you have this included in your machine, definitely it assists, it helps us to quicken the analysis by using GPUs.
Dharmendra, you are unmuted. I hope your query is resolved. If you have any more queries, you can ask.
Hello.
Hello? Yeah.
Actually, is there any specific graphics card or something which support GPU acceleration?
It should be the regular one.
Any graphics card?
Yes, with more than 2 GB should always be helpful. NVIDIA graphics card will be there, or any other graphics card. But also, the GPU's information need to be input into the machine where in which we are working, so that definitely Abaqus will help us in accessing to the GPU to fasten up the analysis in Abaqus standard.
Okay. So, is there any number of cores input or something?
Sorry.
How many number of cores we can use for the solution? Is that something like that?
Yeah, it depends on the CPUs and GPUs that you are using. So you need to have one extra token when you are accessing the GPUs. So it will be accessible from Abaqus standard. So further information will be shareable. We will share with you information.
Okay. Okay. Right.
Thank you, Dharmendra.
Thank you.
And we have Mr. Sachin Darade. Hi, Mr. Sachin Darade. If you have any queries, you can ask. You are unmuted now.
Huh?
Yes, Sachin.
Hello.
Hello. Yeah, please go ahead.
Hello. Hello.
Hello. Yeah, please go
Huh.
ahead.
Can we use this for checking vibration haptic?
Vibration.
Haptic.
Can you please elaborate the query?
Actually, we are using vibration haptic in our part.
Mhm.
So can we use this your Abaqus for vibration haptic checking purpose?
Yeah, vibrational analysis can be done using this product. There is linear perturbation, where in which you can use and do the frequency model extraction, random response spectrum, all this type of analysis in this.
Okay.
Thank you, Sachin. If you have any more queries, you can post. Please post it in the chat box. Thank you all. The session will be shared with you. The entire demonstration video will be shared to you as well. Yeah, Ravi, you can download the session, the YouTube. Thank you all.